So this is the example of using the a priori algorithm. Yeah. So how can we do this one? Okay, let's see step by step. So given we TDB, okay, TDB means the transaction DB. Okay, this is the transaction DB. And I have minimum support 0.5, and I have the minimum confidence 0.7. Okay. Now we have 4 transactions. The first transaction is ACG. The second transaction is BCE. The third transaction ABCE. The fourth transaction is BE. Okay. The step 1 is to find the frequent item set. Okay, so I already gave you the first one is the frequent item set. How can we find the frequent item set? The first scan is to check the k equals to 1, and we find the support. The support minimum here equals to 2. How can we get 2? How can we get 2? 0.5 multiplied by the number of transactions. So there will be at least 2 in the transaction, and I can say that the item is frequent. Okay. Now I will check A. How many A? We have 1, 2. So there are 2. B, there are 3. C, there are 3. D, we have 1. E, we have 3. Okay, what happens next? We will consider only the item which is higher than the minimum support. So D will E, C, E. The next, so we can say this one. C1 is the candidate when the k equals to 1, and the L1 is the frequent item when the k equals to 1. Now we will go to the second one where k equals to 2. Where k equals to 2, it means I want to combine the item set from k equals to 1. So I want to find the combination A and B, A and C, A and E, and then B and C, B and E, and then C and E. Now I have those candidate. Okay, so C means the candidate, and this is for k equals to 2. I will do the scanning again. So the scanning is based on the data from the transaction DB, and I need to check how many of those items in the transaction. So I can see the AB. Okay, there's only one. AC, there are 2. AE, A and E, there's 1. BC, there are 2. BE, BE, there are 3, and CE, there are 2. Okay. So we can see that this is the candidate after we calculate the support. And we know that the support minimum is 2. So what we can do is just prune the support equals to 1. You can get only the AC, BC, BE, and C. So this is the K equals to 2. Next is, we want to find the K equals to 3. And from the L2, we can get only BCE. Why? If we check from the combination from K1 until K2, we try to find all the combination. But why we don't consider ACE? Why don't we consider ABE? Or why don't we consider ABC? Why we only consider BCE? Why? So it is based on the pruning rules that we learned before. Let's see. If I have ACE, okay, if I have ACE, so this is K equals to 3. What about if K equals to 2? AC, AE, and CE. Okay, based on the rule, if this one frequent, then AC, AE, CE is also frequent. Now let's check. AC frequent? Yes. Okay. AE, is it frequent? No. Okay. There is no AE. Okay. There is no AE here. What about CE? CE is frequent. Okay. Based on the rule, if the superset, okay, this is the superset. This is the superset. The superset can be generated if all the subset is frequent. Because there is one which is not frequent, then we do not need this superset. Let's check the other. ABE. ABE, we can have the K equals to 2, which is AB, AE, and BE. Is AB frequent? No. Is AE frequent? No. Is yes. Only BE is frequent. Then the other two make the superset is not frequent. Okay. Then we have only BCE because the BC, BE, and CE, they are frequent. And after this, we scan how many BCE in the transaction. So we have 2. and we call this is the it doesn't, yeah, we call this the final frequent items. Okay. So this is the final frequent items. After we have the frequent item sets, okay, we have the L1, we have L2, and we have L3. We want to find the association rules. So the association rules means we want to find the X and Y. We want to find the spot and confidence. And yeah, I just give you directly this result. This is from the L2. Why we cannot get the support and confidence for L1? Why? Because in the association rule, we need X and Y. So at least there should be two items. So item 1 will not be available for the association rule. We will start from 2. And from this one, AC, the confidence is 1. CA, the confidence is 0.67. BC, 0.67. CB, 0.67, and so on. Because we have the minimum confidence is 0.7, so we choose only AC, EE, and EB. What about we have the L3? Same with the previous one, we need to calculate the confidence. So the confidence will be, yeah, we can make the combination B, C, and then E. B, E, and then C. C, E, and then B. And also we can have the probability of B, and then C and E. C, and then B and E. E, and then B and C. Okay. And from the confidence value, we will just use this two because the value are more than 0.7. So we got this final association rules. Okay. So this is the pseudocode. This is the a priori algorithm. We have the C is the candidate, and then L is the frequent items, and K represent the K. Okay, so we still remember the K item set. Okay, and yeah, you can follow this algorithm. So the implementation, yeah, you already know the step by step when we get the final association rules and final frequent item. So when we do the candidate generation, so there are two steps, self-joining and pruning. Okay. What is self-joining? So self-joining, when we have the A, B, C, E, then we self-joining to L2, C2, we have A, B, A, C, A, E, B, C, B, E, and C, E. So it's self-joining. And then after we self-join, we prune. Because all of them are based on the L1, and this L1 is frequent, so those are the frequent. So we assume the frequent, and then we scan. After we scan, we know that some of them are not frequent. But the pruning will not use the scanning, but just use the pruning from the a priori rules. So these a priori rules, let's say if I can have this one, ABC, ABD, ACD, ACE, and BCD. This L3. So the self-joining means I can see from those sequence ABCD can be one, ACDE can be another one, and yeah, you can have other possibility. For example, A, B, C, E. This is also possible. Or you can get A, C, D, E. This is also possible. So it's self-joining. After you do the self-joining, you can do pruning. Why? As we worked before, if the subset is not frequent, then the superset should not be tested. If the subset is not frequent, the subset should not be generated. So we do not need ACDE. Why? Because ACDE, we need to have the subset ACD, ACE, CDE, ADE, and okay, therefore. So ACD, is there any ACD? Okay, yes. ACE, is there ACE? Yes. CDE, is there any CDE? It's not frequent. Is there any ADE? No, it's not frequent. Because there are two subsets which is not frequent, so ACDE can be removed. So the C4 is only ABCD. Okay, this is another example. Now the transaction is more than the previous example. Here, this is the transactional data or the transactional DB. And let's have the minimum support 0.2 and the minimum confidence 0.7. Now, the problem is to find the frequent item set and find the association rule. Okay. If we have the minimum support 0.2, so what is the minimum support count? Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it is like 0.2 multiplied by 9. So 1.8. Okay, so the minimum 1.8. Or yeah, you can say the support minimum is minimum 2. So we start from the beginning. We will check when k equals to 1. I1, I2, I3, I4, I5. The minimum support equals to 2. And yeah, all of those are frequent. So the L1 means for all. This is the candidate one. This is the L1. And then after we have the L1, we want to find the candidate when k equals to 2. When k equals to 2, what you can see here is the combination between the item set when k equals to 1. I1, I2, I1, I3, I1, I4, and so on. And from this combination, you can check the support. I1, I2, therefore, I1, I3, therefore, I1, I4, there is 1, and so on. And what is the support minimum? We have 2. So we can just eliminate this one, this one, this one, this one. So the remaining will be the value of L2. Now, after we have the L2, we will generate the C3. See, this is the candidate when the K equals to 3. Okay, and you will get only the I1, I2, I3, and I1, I2, I5. Why? The same with this rule. Okay, if you want to check, there might be the possibility of I1, I2, I4. So we need to check the subset. I1, I2, I2, I4, and I1, I4. I1, I2, frequent? Yes. I2, I4, frequent? Yes. I1, I4, is it frequent? No. Because it is not frequent, then the superset should not be generated. And so on. So we can calculate also the support count, and yeah, this is the result of L2. And after we have this frequent item set, we can calculate the association rules. So this is the association rules. This is the association rules when k equals to 3. This is the association rule when the k equals to 2. So you get the confidence. And from all the confidence, we can just choose the confidence which is higher than 0.7. So it means this one, this one, this one, higher than 0.7. And this one is higher than 0.7. Okay. And those are higher than 0.7 are the association rules. Okay, any questions? Okay, what is a priori algorithm? Okay, you learn from the examples how to prune and etc. It is based on the a priori algorithm. So if there is any item set which is infrequent, its superset should not be generated or tested. True or false? False? True? What is the superset? This is the superset. Okay. So if there is any item set which is infrequent, okay, this infrequent means not frequent. Each superset should not be generated. True or false? The answer is true. Okay. So if there is one item set which is not frequent, then you don't need to generate the superset. Okay. Oh, okay. I still have time. Let me explain that. There is another interestingness measure. We call it leaf. So the idea of this one is from the correlation. Let's suppose we have this data. So this data means, if you still remember the chi-square, you still remember chi-square? Okay, you can check. I think in the chapter 3 or I forgot. So you check again the chi-square. So the idea is similar with the chi-square, but yeah, we call this is leaf, and this is the additional of support and confidence. We learn about the support, we learn about the confidence. Now we learn about leaf. Here, basketball, not basketball, cereal, not cereal. So I can say that if someone play basketball, the person likes cereal. So there are 2,000 persons. Okay. If the person do not play basketball and he like to eat cereal, there are 1,750. Now, this is the support and this is the confidence. How can we get the support from this data? Play basketball is the X, cereal is the Y. Okay. Now we have the formula is X. Okay, yeah, for all the X and Y divided by the number of X. This is for confidence. And if we have the support, we want to calculate for all, and then we want to divide with the total transaction. So in this case, the support will be 2,000 divided by 5,000. The total is 5,000, and the number who play basketball and eat cereal, they are 2,000. What about the confidence? Play basketball and eat cereal, we have 2,000 divided by the number of person who play basketball. So we have 3,000. Okay. Now this result, we call it, this is misleading. Because the number of students who is eating cereal, is 3,750. So from the total, it's like 75%. Yeah, 75% is from the 3,750 divided by 5,000. So among the students who eat cereals, 66% play basketball. Yeah, we cannot see actually the correlation between the two data. And also, if you are making the negation, what is the negation here? Play basketball and not cereal. So we have the support, which is 1,000 divided 5,000. So we can get 20%. And then the confidence is the 1,000 divided by 3,000. So this we call it is more accurate because it's still relevant. Okay. Based on the number of the confidence compared to the number of person who do not eat cereal, it is still reasonable. Then how to handle this issue? So we have the correlation to check whether the two variables are dependent or independent. Or we can say those two variables is correlated or not correlated. If you already did the assignment, okay, based on the assignment, we can see the positive correlation, negative correlation. This also works for this association rule. So we call this is leaf. Okay. The leaf means if I want to know B, not C. B means the basketball. Not C. Not C is the negation of C. C is cereal. The negation is not cereal. Okay. So I want to know the probability of A union B. So you can see this is the A and B, okay, divided by the probability of A multiplied by the probability of B. Now, let's see. If I have the B, not C, basketball, not cereal, so it is 1,000 divided by 5,000 because we want to get the probability divided by 3,000 divided by 5,000. What is it? The probability of A. The probability of A means the probability of the people who play basketball. There are 3,000 people who play basketball. So, among all the population, it means 5,000. So there are 3,000. So 3,000 divided by 5,000. And then we want to multiply with the not cereal. The probability of is 1250. 1250 divided by 5,000. Then the result is 1.32. If we have another name, B and C, what is the result? B basketball, C cereal. So it means 2000 divided by 5,000. This is the probability of both. And then we want to find the probability of A. Probability of basketball is 3000 divided by 5,000 multiplied by cereal. 3,750 divided by 5,000. Okay, and we can get the value 0.89. If the leaf is higher than 1, then it has a strong positive correlation. Or we can also see like if leaf less than 1, it shows the negative correlation. If leaf is sorry, not 0. If leaf exactly equals to 1, then it is no correlation. Okay. So leaf equals to 1, then no correlation between 2. In the domain of association rule, there are many interestingness measures. So these are the table. Yeah, you can use the pi coefficient, use Q, use Y, cohen, and etc. Yeah, we don't need to learn all those things. If you want to know more, you can check from this table. But at least we learn support and confidence. So let's see like this one. If someone buy walnuts, and I want to know how big is the probability that someone buy milk, you can see if this one is support, and this is the confidence. The support is 1%. Okay, as I mentioned to you in the first time, the support can be very small, but there might be a possibility to have high confidence. So are you sure with this one? The 80% is only based on the high walnuts. Okay, if you still remember the x, y divided by the number of x. So it means the denominator is the 5 walnuts. So if there is only a small number of people who buy walnuts, then the confidence is higher. Then it can be misleading. So support and confidence are not good to indicate correlation. So that's why we learn about this. And you can use the chi-square. The chi-square you learned before. Yeah, you can use it for finding the correlation. So there are 20 interestingness measures. Okay, so yeah, at least 20 here. And question is, which are good ones? Yeah, it depends on your data set. We cannot say that this one is best for all, but there should be one measure that's good for your data set, but not good for other data set. Okay, I think I will leave this one in the next class. Okay. Any questions? Yeah, we already learned the basic concept, and we learned the examples to use the a priori. And we learn about the interestingness measures. So in the next class, I will teach you about the orins, and I will continue with the next chapter. Any questions? So for the team project, okay, let's wait until next week. So I will for your questions. Okay, there are some questions from you about the team members, but I think some students need to discuss with the other team members. And I think on Monday, I will give you some idea about the topics for the project. Okay. Okay, if you don't have any questions, then let's wrap up the class. Now I want to get your feedback about this online course. So for you who joined the Microsoft team, any problems during the course?
No, it was perfect.
Okay. Then, yeah, I think I will continue to do this one. Okay, so from next week, it's up to you whether you want to join the online or you want to join the offline. But of course, if you join the offline, now there are 2 students who join the offline. So if you have any symptoms or if you have any fever, then please do not come to school. Okay, so you can just join the online. And yeah, if you don't have any chance to join the online or offline, I will upload this course into my storage, and I think I will share it also in the YouTube or in my storage. Okay, so you can review again. Okay, I think that's all. So thank you very much for today. Have a good vacation tomorrow. Have a good long weekend, and see you on Monday.
Thank
you,
you.
sir.
Thank you.
See you.
Sir, I have one question.
Okay.
How can I get team members? We study online, so I have no idea who study in this class. So
Yeah. Okay. So on Monday, let's discuss it more. Okay.
okay, sir.
I
Thank
think
you.
some students are still looking for the good team members.
Yeah.
So Monday, I think I can decide.
Okay, thank you.
Yeah. Okay. Any other questions?
Professor, I have a problem with Microsoft Team.
Oh, okay.
Before break.
Yeah.
So, will you upload today class in eClass?
Yes.
Okay.
I
Thank you.
recorded class, so I will upload this one.
Okay. Thank you.
Okay. Yeah. Any other questions? Okay then. Yeah. Enjoy your day. See you on Monday.
Thank you, sir.